Today we're going to take a look at the example of proving a limit using the formal definition of a limit, right? So let's get started. What our function says is that limit as x approaches 2 of 2x plus 3 is equal to 7. So how we prove this? By using the formal definition of a limit. Well, first let's rewrite a sentence, but in this case we want to replace the variables in our definition by what we have here, right? So first, let's get started. Well, for every epsilon bigger than 0, there exists a delta bigger than 0 such that 0 is smaller than the absolute value of x minus, well, in this case, our a is 2. So absolute value of x minus 2 is smaller than some arbitrary small value delta. Implies that our f of x in this case will be, well, 2x plus 3, right? So 2x plus 3. And then minus our L in this case, which is 7, is smaller than some arbitrary value epsilon, right? So before we begin the formal proof of this thing, we want to do something that we call the rough work, which you will see the importance later. But let's write it: rough work. So just R and W. Okay, so as you can see in this case, we have our expression 2x plus 3 minus 7 is smaller than epsilon, which we could expand by using algebra. Well, this will becomes 2x. Well, what is 3 minus 7 is, well, negative 4 is smaller than epsilon. And then what you could do is that you could take factor 2 out of it, which then it becomes 2 times absolute value of x minus 2 is smaller than epsilon. And then we can say that absolute value of x minus 2 is smaller than epsilon over 2. And then this will be it for our rough work. Now our formal proof begin. So let's write it in our red pen. Well, when you start a formal proof, what you always want to write is that you always want to write the thing that you want to show first. So in this case, I want to write 1 to show for every epsilon bigger than 0, there exists a delta bigger than 0 such that 0 is smaller than x minus 2, smaller than epsilon. I mean delta, sorry. Implies that 2x plus 3 minus 7 is smaller than epsilon. And then we have what we have developed from our rough work is that we want to choose delta to be equal to epsilon over 2. So this is what we want to do here, right? So let's just let that be one of our assumption. Okay, so as you can see, well, f of x minus L, which is in this case 2x plus 3 minus 7 smaller than epsilon, can essentially be written as, well, we'll just simplify it again, 2x minus 4 is smaller than epsilon, which then becomes 2x minus 2 is smaller than epsilon. And then if you look at our assumption right here, right, our assumption says is that, I'm going to use green pen here, our assumption says is that our absolute value of x minus 2 is smaller than delta. So therefore, what we can replace our delta right here, well, let's write it like this. So let's write it as 2 times absolute value of x minus 2 is smaller than 2 times delta, right? Because our assumption is that delta is bigger than absolute value of x minus 2. So of course we can replace it in an inequality like this because delta is bigger than absolute value of x minus 2, right? And then one of our assumptions says is that so let's keep writing it here. We chose, let's write it, wait. We chose epsilon, we chose delta to be equal to epsilon over 2. So therefore 2 times the absolute value of x minus 2 is smaller than 2 times epsilon over 2, right? Because we're just replacing delta with epsilon over 2, which is what we chose in our rough work, right? So then this becomes 2 times, well, the 2 and 2 cancel each other out. Then this becomes 2 times x minus 2 is smaller than epsilon. Or in other words, if we expand back to this expression here, this will show that 2x plus 3 minus 7 is smaller than epsilon, which is what we want to show, right? So if you look at the analyze of what we just did here, we've analyzed what we just did here, right? Well, we first did some bunch of rough work to choose or to find a expression of delta in terms of epsilon. In this case, that delta is equal to epsilon over 2. Then we write in our case of formal proof. Well, in the formal proof, what you want to do first is that you want to write what you want to show. So we first write down what you want to show, which is this whole expression right here, right? And then we also write down our assumption is that we want to choose that delta to be equal to epsilon over 2. Then we start expanding our expression here, which is this part. We start expanding our expression, and then we lead to the conclusion that 2 times absolute value of x minus 2 is smaller than epsilon. Well, if you only look at this expression right here, right, you will know that that is actually smaller than 2 times delta, because in our assumption, right, we say that absolute value of x minus 2 is smaller than delta. So therefore, we can safely say that 2 times the absolute value of x minus 2 is smaller than 2 times delta. So, right, so then another assumption of ours is that delta is equal to epsilon over 2. So therefore, we can say that 2 times the absolute value of x minus 2 is smaller than 2 times delta, and delta in this case is epsilon over 2. So 2 times epsilon over 2 is epsilon. So we use our assumption to reach the conclusion that 2x plus 3 minus 7 is indeed smaller than epsilon when we have our assumption that absolute value of x minus 2 is smaller than delta. So we have successfully proven this equation, or this limit right here, by using the formal definition of a limit.